All right, guys, this is going to be the lecture for homework 20. The idea here will be parallel and perpendicular lines. It's pretty imperative that you go back perpendicular, that you go back and make sure you are comfortable, with the lecture from homework 19, because this is pretty much going to build off that. What we did in homework 19 was we wrote equations, right? Here's some information, write the equation of a line. We had sort of a generic three-step process. One, we said find the slope. Because remember, generally speaking, we're looking for y equals mx plus b, right? I don't know why I tried to scribble that in there. We're looking for y equals mx plus b. All right, just keep that in mind, generally speaking. What would the exceptions to that be? If it tells you to leave it in point slope, or if it's a vertical or horizontal line, right? Because remember, those are different. So first we find the slope. Maybe they give it to us, maybe they don't. Second step was get the y-intercept, because that's the b, right? If you have the slope, you have the m. If you have the y-intercept, you have the b, and then you're done. The third step was if there was no y-intercept, which was what homework 19 was about, then use point slope. There are other ways to do it. Some of y'all emailed me and said, hey, I know another way to find y equals mx plus b without using point slope. It doesn't really matter to me. Just, again, remember on the test, there might be a question or something that says leave the answer in point slope. So even if you don't technically, feel like you have to use it to get to y equals mx plus b, make sure you know how to use it in case we ask you a question about point slope. So that's what we went over in homework 19. Homework 20 is concerned with parallel and perpendicular lines, but still you're going to be writing equations. So this three-step procedure is still something you're going to want to keep in mind, okay? So I won't write it again, but just, if this is something you want to, work along with, keep these to the side because I will be referring to them. So we'll start with parallel. And while it's not imperative that you understand what they look like, it's important, for the moment, because right now we're writing equations. Parallel lines are two lines that run next to each other and never touch if you draw them correctly. Something like that, right? Like two lanes on a highway. If you stay in your lane and I stay in my lane, we should never touch, that kind of thing. But that's not really the point. It is, what you need to know. That is what parallel lines are, but that's not really the point. Because remember, we're talking about what is the equations of parallel lines. Well, if parallel lines run in the same direction and never touch, what could you say about their equations? Couldn't you say they have the same slope? And this is the key point right here. This is of all the things I've said so far, this is the new material. Parallel means same slope. What would the slope be for this horizontal line here? Hopefully you know it to be 0. Well, what would the slope be for that horizontal line? 0. What's the slope for this vertical line? Remember we said that's undefined. Well, what would the slope be for that vertical line? Undefined, right? And then up here, let's just say this one went up 1, 2 over 1. This one's going to go up 2 over 1, right? Either way, the slope is the same. That's the key point. Don't forget it. Parallel lines have the same slope. That's the point, all right? Let's get perpendicular down here and go ahead and box it in. Because again, really, if you understand homework 19, homework 20 is not going to be much of a big deal for you. Perpendicular lines, are lines that cross at a perfect 90-degree angle, okay? Again, if you draw it right. But this is not trig. We're not looking at you to calculate angles or anything like that, but they have to be a perfect 90 degrees, and we usually indicate that with a little square. Because again, your eyes aren't good enough to tell the difference between 90 degrees and 89.9 degrees, you know what I mean? So it's not about really what they look like, but it's not just any lines that cross. They cross at a perfect 90 degrees, like a T, right? But again, we're not super interested in the picture. We're more interested in the equations. So for the equations of perpendicular lines, what matters is we have what's called opposite reciprocal slopes. It's a mouthful. Opposite reciprocal slopes. What does that mean? Opposite meaning they're different signs. Reciprocal meaning you flip. So for example, let's say that your slope was 2/3. The opposite reciprocal slope of that, opposite meaning, well, yours is positive, so mine's going to be negative. And reciprocal meaning, well, yours is 2 over 3, so mine's 3 over 2. That's what perpendicular means. The slopes are opposite, completely backwards from each other, right? Technically, 0 and undefined are opposites. So when you have a vertical line, it's undefined. When you have a horizontal line, it's 0, and those are technically opposites, just FYI. Another example here, what if I said my slope was -5? What would the opposite reciprocal of that be? Well, yours is negative, so mine's positive. Yours is 5 over 1, so mine would be 1 over 5. Is that making sense? We'll do some examples with it, but that's really the idea here. Parallel lines mean the slope is the same, identical, whatever the slope of this line is, that's the slope of that line. So parallel are a little easier, I guess. Perpendicular lines, it's opposite reciprocal. You take the number, change the sign, and flip it. Let's do one more, just squeeze it in real quick here. What if I said my slope was -1/8? What would the opposite reciprocal slope to that be? Well, if mine's negative, opposite means yours is positive, and 1 over 8 means yours is 8 over 1, which is just 8, right? So -1 over 8, opposite of that, opposite reciprocal of that would be +8, okay? So take a minute, make sure you got the definitions here, and then we're just gonna, that's really the only new material in this homework, so there's not a lot new here, and then we'll just do some problems, okay? And honestly, a lot of the problems we're gonna do is the stuff we were doing from 19, we're just gonna be using the words parallel and perpendicular, all right? So let's just go ahead and jump right into that. 18, 19, and 20, because they're coming all in one short time period for y'all. These are probably the most involved set of homeworks you're gonna have in the class. Make sure you, don't sleep on these. So let's say it said write the equation, because like I said, for the most part, that's what we're concerned about right now. Write the equation of a line. Let's say it said parallel to y equals 3x plus 7, just whatever. And then they're going to say going through or passing through, I don't know, 1, 12, something like that. So this is a pretty typical question. Write the equation of a line parallel. Again, I'm abbreviating a little bit here. Write the equation of a line parallel to y equals 3x plus 7 going through 1, 12. The steps are the same. Remember, what did we just say? Let's go back to that first page. Just like homework 19, when you want to write the equation, wrote the equation, holy cow, write the equation. You want to find the slope. You want to get the y-intercept. If you can't get the y-intercept, or if you just don't have it, then you're going to have to use point slope, all right? So first step for us is to get the slope. So what is our slope? Because we need an equation that's parallel to this line and that goes through this point. So that's their line. That is not our line. This is our point, and we need an equation parallel to that. Well, parallel means what? It means the slope is the same, right? So if their slope is 3, so is yours. That's all that was. That's the only thing parallel does in this whole problem, is it basically says same slope. Write the equation with the same slope as this. Okay, so my slope is 3. Now, is my y-intercept 7? No, because if my y-intercept was 7, then you'd have the exact same line. They wouldn't be parallel, they'd be identical, right? Their line is y equals 3x plus 7. You want one parallel to it, so it does need to have the same slope of 3, but it needs to go to a different point. So what we have is 3 and 1, 12. You have a slope and a point. You have a point and a slope. Slope, point, point, slope, point, slope, slope, point. You get what I'm saying? You might want to use point slope formula. I mean, I'm being funny, but I'm not, It's just, that's the thing. When you're on the test, if you're like, oh my God, I got a point, I got a slope, I don't know what to do with it. The name of the equation is what you're supposed to do. What you have is what you're supposed to use. I have a point and a slope. Use point slope. Remember, this is the version of it I use. There are 2 versions of it. Again, we talked about that in 19. So first step was to find the slope. We did. Second step was to get the y-intercept. Don't fall for this. That's their y-intercept. It's not your y-intercept. Parallel doesn't mean everything's the same. It just means the slope's the same. So we had a slope, no y-intercept, just some other random point. So now we'll have to do point slope. So y equals 3 times x minus, again, remember the only point we have here. So that would be x1, y1. X minus x1, which is 1. Plus, in this case, because it's positive, plus 12. And remember, if they told you to leave it in point slope, you're done. It just depends on the question. I will always have us go to y equals mx plus b, just go all the way. 3 times x is 3x. 3 times -1 is -3, plus 12. Don't forget the plus 12. 3x, -3 plus 12, that's plus 9. Y equals 3x plus 9. Does that make sense as an answer? Well, is it parallel to that line? Yeah, 3x and 3x. So you know at least that much is true. Okay? And All of this was just from homework 19. So if this is the part that threw you off, go back to 19. The only thing new here was that instead of saying, oh, your slope is 3, it said, well, you're parallel to this line, which means their slope is 3, so is yours. Parallel and perpendicular is just another way to tell you what the slope is. And that's really the bottom line with that. Let's go ahead and get another one in here. Let's say I said, write the equation. You know what? No, there's not enough room. Let's just do it on another piece of paper. It's not going to work. Let's just avoid that mistake before it happens, right? Paper's cheap. Y'all paid enough. We can do a fresh sheet of paper, I guess. All right, so write the equation. Let's do perpendicular this time. So write the equation of a line. Perpendicular to, let's make something not super nasty, but not super easy. -1/2 x plus 4, right? Perpendicular to that and going through, passing through, whatever you want to say. Going through 3, -1. Some negatives in there, some fractions in there, you know what I mean? This is more down the line. The last one was a little easy. Parallel is not too bad. Perpendicular is a little more tricky. First step is to find the slope. If it says write the equation of a line, first step is to find the slope. So if their slope is -1/2, what is your slope? Well, perpendicular this time. So it's not the same, right? We're not going to say it's the same. That's parallel. Perpendicular means we're going to make the opposite. So theirs is negative. Ours will be positive. Theirs is 1/2. So ours will be 2/1. But isn't that really just 2? Positive 2/1. I mean, isn't that just 2? So your slope is 2. That's all that had. That's all that first bit says. Write the equation of a line perpendicular to blah, blah, blah. All that says is your slope is 2. As long as you know what perpendicular means and you know what to do with their slope to get there, it's just 2. Don't forget, you flip it and change the sign. 2 things. So now we got a slope that's 2. We got a 0.3 comma -1. Hopefully you know what to do now. Point slope. Y equals m, which is 2, times x minus 3. And then our y1 is -1, so just put -1 there, remember? And then we just work it out. So hopefully you see these aren't too bad. It's really just more stuff from homework 19. But you just got to make sure that you know homework 19 before you start messing with this. Because all we've done really is make homework 19 and just step it up a little bit by adding parallel and perpendicular, okay? So no big deal there. Hopefully that's making some sense. There can be a little bit trickier problems. We'll get to those in just a minute. But let's do one more sort of, kind of standard problem here before we get into the uglier stuff. Not that it's anything different. It's just there are a few problems that are, maybe not as straightforward as the others. And here's one thing they can do to kind of step this up on you. And this can be confusing just because there's a lot of words. So let me write this out carefully. Let's say we said, I want you to write the equation. This is out of the homework too. This one right here. This one is out of the homework. It's a little bit wordy, so I wanted to do it with you guys. Write the equation of a line going through. Let's see. I wrote a -4, 4. And here's the thing, it's going to be a little different now. And perpendicular to a line with an x-intercept, right? Remember x-intercepts of 3, 0, and a y-intercept of 0, -6. So take a minute, get all that down, read it, comprehend it. They want you to write the equation of a line that is going through this point here, and that is going to be perpendicular to a line which goes through this x-intercept and that y-intercept. If you take all this in at once, it's like going and getting a sip of water off a fire hydrant. You know what I mean? Like, good luck. Take it easy, take it slow, one step at a time. First thing it says, write the equation. So we're into that 3-step procedure again. First, get the slope, then get the y-intercept, blah, blah, blah. So first thing we need to do is find a slope. They didn't give us a slope anywhere, right? It says write the equation of a line that goes through -4, 4. So we know that our line needs to go through that point. But then it doesn't say anything about the slope. It just says, well, perpendicular to, and then a line with some more points. So how do we get the slope? And that's what usually sticks people here. Once they get the slope, they know what to do, but here they didn't know. A lot of times when I think I gave this on a test, maybe even last semester, and of the folks that missed it, that was what they said, is I just didn't know what to do. I didn't know how to begin. So you need to be perpendicular to this line. Think about the last problem we just did. It was perpendicular to this equation, and all we did was take the slope and flip it. The problem is this time they didn't give us an equation. They gave us 2 points. Well, we know how to make a slope with 2 points, don't we? Wasn't that homework 18, right? Remember, m equals y2 minus y1 over x2 minus x1. Remember that formula? Well, we're going to need it here because all they gave us was 2 points to use, so we're going to have to use those to find the slope. It didn't give it to us straight up. Remember, which point you call x1 and y1 does not matter. Just pick one of them. Now, be careful. We should say kind of one clarifying remark here before we begin. Make sure you understand the difference between what is yours and what is the line you are comparing to. So what is yours and what is theirs? Write an equation of a line going through this point. So your point is this. You're perpendicular to the rest of this. So all of this here, this is not your points. These are not your points. These are the points of the line you're comparing against. Just don't forget that. So y2, which is -6, minus y1, which is 0, over x2, which is 0, minus x1, which is 3. That gives us -6 over -3, which is just 2. So their slope was 2, okay? Well, that's great. That's their slope. So now what? We needed our slope. Well, that's the perpendicular bit, right? Perpendicular means what? Take their slope, which is 2, change it to the opposite. So theirs is +2, ours will be negative, and flip it. Theirs is 2 over 1, so ours will be 1 over 2. And now we have a point and a slope, and it's back to point slope. Y equals m (-1/2) times x minus x1. Now remember, we called that one x1 and y1, but those are not our points. We're done with those. This is your point. When you get down to point slope, make sure you're using your point and your slope, right? X minus x1, which is -4. Be careful with that double negative. That messes people up a lot. Y1 is +4. And inside, once you've done this, you can go ahead and just say, well, that's x plus 4. But just make sure you understand why it's +4, okay? So we got -1/2 times x, that's -1/2 x. -1/2 times 4, just think about it. What's half of 4? It's 2. And negative times positive is negative, so that's -2 plus 4. So in the end, we have y equals -1/2 x plus 2. So that was a bit of a longer one, a bit maybe even of a trickier one. Take a minute, make sure it makes sense to you. Think about what we did here. We wrote the equation of a line, same normal steps. We found the slope first, except this time we wanted to find their slope. And then because we were perpendicular, we said we flip it and change the sign, which gave us our slope. The point we had straight up from the beginning. Once you have a point and a slope, point slope, okay? Hopefully that's making some sense. The other way this can show up, and you might even consider these easier than what we were just doing. The other way this can show up, because it's not all writing equations necessarily. I mean, they do want you to know the definition of parallel perpendicular. So another way this might show up is they might say, well, look, here's 2 lines. Y equals -3 over 4x minus 3, you know, whatever. And then 4y minus 3x equals 7. And they might just say, hey, okay, are these parallel? Are they perpendicular? Or are they neither one? Because remember, it's not one or the other. Parallel means they have the same slope. Perpendicular means they have opposite reciprocal slopes. Neither just means they're different. Like one slope would be 7 and the other slope would be -2 or something like that. So they're not asking you to graph it. They're not asking you to write equations of lines. They're just simply asking you, are they parallel, are they perpendicular, or neither? What students like to try to do sometimes is graph them. Remember, if you graph 2 lines and they cross, that doesn't make them perpendicular. They need to cross at a perfect 90-degree angle. Don't try to graph them, because then you're going to try to look at it and say, oh, is that a perfect 90-degree angle? I'm not sure. That's not what we want to do here. Let's compare slope. The first line is in y equals mx plus b, so the slope is straight up, -3 over 4. The second equation is not in y equals mx plus b, so we probably want to get it there. So let's review that. Remember how this goes. We want to get y by itself, so let's add 3x to both sides. Hopefully this is all coming back, right? 4y equals 3x plus 7. We want to get y by itself, so divide by 4. Remember this from the solving homework. So all this turns into y equals 3 over 4x plus 7 over 4. So the slope for this one was 3 over 4. Parallel? Not parallel because they're not the same. Perpendicular, right? No, because perpendicular means they're opposite, but it also means reciprocal, which means they should flip. So these can't be 3 over 4 and 3 over 4. One of them needs to be 4 over 3, so they're not perpendicular either. It's just two different lines. Be careful. Just because they're different signs does not make them perpendicular. Perpendicular means different signs and flipped. Okay, so be careful. Let's do one more problem, probably the trickiest one in the homework. And it's actually not. I mean, it is, but it isn't. I'm not going to do a lot of work here. You're going to see what I mean in a second. Let's say they ask you to write the equation of a line perpendicular, because that's always the one's a little tougher than parallel, perpendicular to x equals 5, going through -11, 4. What would you even do here? So this is another one. This is one that just stumps students dead in the tracks sometimes, and they'll just say, I have no idea what to do. Because that's not a normal line, right? Perpendicular to that, what does that mean? So let's go through the thought process here. Watch how this works, because I'm going to do very, very little math. This is simply just a recognizing facts, which is why this problem can be tough. If you recognize the facts, this is not going to be hard at all. If you don't know your facts, your definitions, my problem might be impossible. So I look at this and I say, I need to write the equation of a line. First thing I need to do is find a slope. Well, I'm perpendicular to this line. What's the slope of that line? Well, what kind of line is that? So here's the first thing. You better realize that that's a vertical line. They're not going to tell you that. You need to recognize it because of the equation, which means the slope is undefined. Well, that still doesn't really help us, does it? That's a vertical line and the slope is undefined. We're supposed to be perpendicular to that. Well, how do you take undefined and flip it, right? Perpendicular means change the sign and flip it. How do you change the sign of undefined and flip it? Well, you don't. So we're kind of stuck. And I think this is where most people get. They recognize that it's a vertical line. They know the slope's undefined, but they don't know how to do perpendicular to that. Well, think about what a vertical line looks like. Yeah, something like this. You're trying to be perpendicular to that. So wouldn't you want a line that goes horizontally? Wouldn't that be perpendicular, assuming I draw it right? Wouldn't that be perpendicular? So if their line is vertical, you can't take the slope and flip it because it's not even a number, so that's out. But perpendicular to a vertical line, that means you want a horizontal line. That means our line should be a horizontal line because we are perpendicular to a vertical line, simply by the way they line, the geometry of the lines. A vertical line goes up and down. Perpendicular means it crosses at a perfect 90 degrees, so horizontal. Well, we need to come up with an equation of a horizontal line. Well, hopefully you remember the equation of a horizontal line is y equals some number with no x. Well, what's the only y value you were given in the entire problem? 4. So that's the answer, y equals 4. So let's go through that again. Write the equation of a line perpendicular to x equals 5 going through -11, 4. Here's the thought process, and here's how this should go down in your head. That's a vertical line. The slope is undefined. I need to be perpendicular to that, but perpendicular doesn't help me when the slope's not a number. Perpendicular does mean, though, that they cross at 90 degrees. So if that's a vertical line, then what I must be making is a horizontal line. So I need a horizontal line, which has the equation y equals some number. No x. Well, what's the only y value you could possibly use in the entire problem? 4. See what I mean? It's an easy problem if you recognize all the definitions. If you don't and you're struggling with, vertical and horizontal and which one is 0 and which one's undefined, then this is just going to get even harder. Make sure you learn the vertical horizontal. Make sure you learn the definitions, guys. It does matter. Okay? That's homework 20, and I'll see y'all in the next one.